you think Earth feels big. A quasar destroys that illusion instantly, because somewhere in deep space there are objects so violently powerful. They outshine entire galaxies. Compared to them, Earth barely exists at all. How big is a quasar compared to Earth? Imagine holding the sun in your hand. Now imagine that sun is a grain of sand, and next to it, floating in space, is a beach ball made of pure light, screaming energy across the cosmos with the brightness of 4 trillion suns. That's a quasar, and it's about to make you feel very, very small. Right now, 13 billion light years away, there's a quasar called J03131806. It's so bright that if you placed it 33 light years from Earth, the distance to a nearby star, it would shine as bright in our sky as the sun. Except the sun won't vaporize you from 33 light years away. A quasar would erase you, your atoms, your planet, your solar system. The light alone would strip Earth's atmosphere in seconds. The radiation would sterilize everything within 10,000 light years. And the terrifying part? That quasar is real. It exists. And it's been screaming into the void since the universe was barely 700 million years old. But here's the question that breaks your brain. How big is it actually? How does something outshine 4 trillion suns? What does that even mean? Because when scientists first discovered quasars in the 1960s, they thought they were stars. Compact, small, manageable. Then they measured the energy output, and reality collapsed. Let me give you the comparison that changes everything. Earth is 12,000 kilometers wide, a sphere of rock and water and life rotating peacefully around an average star. You could fit 1 million Earths inside the sun. The sun is massive, incomprehensibly massive to human perception. Its diameter is 1.4 million kilometers. It contains 99.8% of all mass in our solar system. When you look up at the sun, you're seeing something so large that light takes 4.6 seconds to travel from its core to its surface. Now forget the sun, because a quasar isn't a star. It's not even comparable to a star. A quasar is a supermassive black hole, millions to billions of times the mass of the sun, actively feeding, devouring everything nearby. Gas, dust, stars, entire solar systems spiraling into oblivion. And as that matter accelerates toward the event horizon, friction heats it to millions of degrees. It glows, brighter than anything else in existence. The accretion disk, the swirling maelstrom of doomed matter orbiting the black hole, can span light years across, not kilometers, not millions of kilometers, light years. The distance light travels in 1 year, 9.5 trillion kilometers. You could fit our entire solar system, sun, planets, Kuiper belt, everything inside the accretion disk of a supermassive quasar hundreds of times over, and it would vanish like a pebble dropped into an ocean. But that's not the scary part. The scary part is the jets. When a quasar feeds, it doesn't just glow, it fires. Twin beams of superheated plasma explode from the poles of the black hole at 99.9%, the speed of light stretching across space for hundreds of thousands of light years. These jets, these cosmic flamethrowers, are powered by magnetic fields so intense they warp space-time itself. If you could see one with the human eyes, it would look like a lance of pure energy stabbing through the universe, bright enough to illuminate galaxies millions of light years away. Earth, in comparison, is invisible, microscopic, irrelevant. Let me make this physical. If a quasar's accretion disk were the size of a football field, Earth would be smaller than a single atom on the 50-yard line. You wouldn't see it. You couldn't see it. Even if you were standing on the field, staring directly at where Earth should be, it wouldn't register. The scale difference is so extreme that it breaks human comprehension. But here's where things become existentially disturbing. Quasars aren't rare. They're everywhere. Well, everywhere in the early universe. We've detected over 1 million of them. Most are billions of light years away, meaning we're seeing them as they existed billions of years ago when the universe was young and violent and galaxies were still colliding. Back then, quasars dominated. They were the brightest objects in existence. They shaped galaxies, They sterilized regions of space. They were the universe's immune system, burning away potential before life could even begin. And here's the part that should keep you awake at night. Every large galaxy has a supermassive black hole at its center, including ours. Sagittarius, a star, the black hole at the heart of the Milky Way, has a mass of 4 million suns. Right now, it's dormant, quiet, sipping gas occasionally, glowing faintly in radio waves. But it wasn't always dormant. Billions of years ago, the Milky Way had a quasar at its core. Our galaxy was once one of those screaming monsters firing jets across space, glowing brighter than 1 trillion stars. It stopped feeding. The quasar turned off. And in the silence that followed, life became possible. But what happens if it wakes up? Because quasars don't die. They hibernate. When a supermassive black hole runs out of nearby material to consume, the accretion disk fades. The jets shut down, the quasar goes dark, but the black hole remains, waiting. And if enough matter falls back into the center of the galaxy, if 2 galaxies collide, if a giant gas cloud drifts too close, the quasar reignites. In 4 billion years, the Milky Way will collide with Andromeda. 2 galaxies merging. 2 supermassive black holes spiraling toward each other. When they meet, the energy released will dwarf anything humanity has ever witnessed. Gas will flood the center. The black holes will feed. And for a brief, terrifying period, our galaxy will birth a quasar again. If Earth still exists by then, if humanity has somehow survived, we'll be living inside the brightest object in the local universe. The radiation will be catastrophic. The jets could sterilize half the galaxy. Life as we know it won't survive. But let's return to size, because the numbers are one thing, the feeling is another. Imagine standing on Earth looking up. Now imagine the sky isn't blue, it's white, pure searing white, brighter than 1,000 suns, bright enough to burn shadows into stone. That's what it would look like to live near a quasar. Except you wouldn't live. You'd be vapor, your molecules stripped apart by radiation, your atoms ionized, your existence reduced to plasma and scattered across the accretion disk, spiraling into the event horizon, crushed into a singularity where space and time cease to exist. The quasar wouldn't notice. It would keep feeding, keep glowing, keep firing its jets into the cosmic dark. Because to a quasar, Earth isn't a planet. It's not even dust. It's a quantum fluctuation. A rounding error. A thought that never finished forming. And this is where the existential weight settles in. We exist only because quasars stopped. The early universe was so violent, so flooded with radiation from feeding supermassive black holes, that stars couldn't form properly. Galaxies couldn't stabilize. Life was impossible. It took billions of years for the quasars to go dormant, for the universe to cool, for quiet regions of space to appear where solar systems could form and planets could develop atmospheres and liquid water to pool on surfaces and chemistry could become biology. We are alive in the silence between screams, but the screams haven't ended. They've just moved farther away. Right now, 13 billion light years distant, quasars are still raging, still feeding, still sterilizing entire galactic neighborhoods. And the light we're seeing from them is ancient. We're watching the past. We're seeing the universe as it was when it was young and brutal and unfit for life. What we don't know is what's happening in those regions right now, today, in real time. Has the quasar we're observing already gone dark? Has it been dormant for 10 billion years? Or is it still feeding, still growing, still building towards something we can't predict? We won't know for billions of years, because the light showing us the answer is still traveling, still crossing the void, still carrying information about events that happened before Earth existed. And here's the final, crushing realization. If quasars are this massive, if they dwarf Earth so completely that our planet is comparable to an atom, then what does that say about us? About our civilizations, our wars, our art, our love, our fear? We're building cities on a speck of dust orbiting an average star in a galaxy that once hosted a quasar so bright it could have been seen from the edge of the observable universe. We matter on Earth. We matter to each other. But to the cosmos, To the quasar that once lived where our galaxy now rests, we're less than nothing. We're an accident. A brief chemical reaction happening in the quiet aftermath of something unimaginably violent. And one day, billions of years from now, when Sagittarius A star feeds again, when our galaxy births a new quasar, when the jets ignite, and the accretion disk glows, and the radiation floods outward, erasing everything we've ever built. Everything we've ever known, the universe won't notice. Because to a quasar, Earth was never big enough to see in the first place.